Hello, Aureline. This is Joad.
Hey, Jawad, how you doing today?
I'm doing well. So this meeting is for the proof of concept. I'm assuming that's what you're interested in, right?
Yes, I am here to learn what's going on with the group. Honestly, yes, that's what I'm interested in, but I'm here to learn. This is probably my first or second time calling in this meeting.
Okay. Yeah, so I can probably give you a little bit of a background and what we are trying to do with this particular work stream.
Hmm.
Um, so the big idea behind proof of concept is to actually build a system, design it in EDA or with the design automation software, and then actually take it to manufacturing.
Okay.
So we have previously done some of this work. We've created boards and packages in the past, and now I was waiting for David Rajkov to join. He has been doing some of the work on design of a system on glass interposer.
Okay.
So we are now looking at some of the other industry partners who have their own proof of concept that is ongoing, such as we understand that ARM and Cadence are doing a proof of concept around their ecosystem. So, the learning that we have in OCP here in these groups is more generic, more publicly available
Yep.
than closed ecosystems. That's essentially the uh, thing that we bring to the table. So at the moment, we are more of in a discussion phase, which is like, what are the interested parties that are willing to come together to pull off a, a proof of concept system. So,
Hmm.
so we have a number of volunteers who usually log into this meeting, but today there is really just myself and I was waiting. So I'm happy to learn what is your interest because part of the thing that I do myself is co-lead the Open Chiplet Economy project at
Hmm.
OCP and overseeing the activities of all these work streams and aligning them with the general objectives of everybody involved.
Yeah. Yeah. So honestly, when I saw the chiplet economy, I wasn't 100% sure exactly what the Workstream does, so I signed up to kind of learn. I am want to understand what's going on in the OCP community as far as chipless is concerned, and I'm looking to where I can contribute and collaborate. Because that's part of the work that I do. Of course, a lot of stuff that we do here at Altera. I'm part of Altera, by the way. That is the FPGA division of Intel that Intel is spinning off. So a lot of the work that we're doing here is, as far as chiplet is, of course, a lot confidential. We don't put a lot of our work out there. But I like that. I mean, I may be wanting that to change a little bit and to see where personally I can contribute first, and then kind of see if there is something that would within our community we will want to make it out there a little bit public. And there are stuff that we have done and we put public, right? We have created, I mean, the AIB box that we put it out there, it is public. The IPs are there, and then it is usable by everybody. But you have something like that like UCIe, that is a little bit more generic. So, right, like us, just like anybody else, we kind of studying that and then seeing if it makes sense and when it makes sense to build a chiplet with that, right? So. But I don't know exactly what this work stream does, so I'm here to learn, honestly. And if along the way, the folks who have ideas, who are leading, there are something where I can personally, technically contribute, I'll be more than happy to roll up my sleeves and
Sure.
contribute.
So there are two ways that people participate. One is that they participate individually, and the other is that they have their company interested in it. Um, then they can basically come through the company, and some of the companies have participated in OCP for their own commercial interests.
Hmm.
And then what happens is that they typically drive some of their own commercial interests that align with the open community, right? Because one of the
Hmm.
difference between the open source software and OCP is that we encourage everybody to have commercial goals.
Yep.
Okay, so that basically most of the cases helps folks. So I think that would be one of the things that you should think through. Now, if you are in general interested in learning about what is happening in open chiplet economy, um, uh, then I would recommend that there is a call pretty much every Friday at 8 in the morning.
Hmm.
And that call is more of a steering committee call where you get to hear the status of various work streams and what's going on in there. I know that there is one work stream called Chiplet Systems work stream
Hmm.
that is very heavily focused on some of the work around AMD's MI300.
Hmm.
Um, this particular one POC at the moment has finished some design work last year, and it's in a bit of a flux where volunteers are coming together and thinking through what's the next project that we're going to work on.
Okay, so the POC that was finished last year, it was something that was, I suppose it is published. I can go in the archives and look at it. Was it actually physically built?
Yes, but the thing is, field is moving so fast that things get outdated very quickly, right?
Yep.
So the in 2018 when we did, or 2019 when we published the very first POC, it was primarily a software development vehicle around the idea of modular designs using chiplets. So
Hmm.
uh, that was published back in 2019 or 2020, I recall. And at that time, the idea of chiplets was very new to the industry.
Yep.
And then the one that this work stream did was, I think, started in 2021 and maybe published in 22 or 23 or some part maybe even later. That was a reference package design using standard packaging. So there were the participants were Google. Google sponsored some part of it,
Hmm.
and I wasn't even involved in that activity, so I'm not going to be able to tell you full information. But yes, there exists a package that by today's standard is outdated.
Okay.
But the thing is, go back 2021, 2022, is standard packaging. There were a lot of unknowns. So
Yep.
people participated, learned a lot from there
Hmm.
on. Now the chiplet ecosystem is much more established, right? So, so yes, you should be able to find the old work. I'm not sure how much useful that is. And
Okay.
that's what we come together and discuss about, right? So we can discuss, and let's say a FPGA company is interested in selling a chiplet, right? What is it that they would want the industry to support them with,
Yeah,
right?
got it.
So, and then, you know, since this is a proof of concept, what one challenge we always run into in last two projects that we've done is when we come to actual fabrication. Fabrication requires some money. Even though we get steep discounts, it does require some money.
Yeah.
And then we go and ask for somebody else to pay those bills.
Yes. So typically a company who will have a vested interest on the technology of an interest of either the technology going out there to be public for other people to use so they can commercially benefit, or they can themselves use the technology.
That's right.
Okay.
That's right. And you know, the thing that we've noticed, and this is not just in the open chiplet economy, it's throughout the OCP, even on the racks and other equipment that gets standardized. People who are taking the lead, they get to own the market.
Yeah. And I think that's where I realized too as well.
Yeah.
So yes, at this moment, I think one of the things, Altera is a company that it's been around for a while, but it's also getting now its action in terms of getting separated from Intel. So the amount of external involvement that we have into driving external project is limited. I mean, there are a few added, but not just in my area, at least not at this moment. So I'm kind of learning a little bit what's going on, and it's definitely not this year, maybe a year or two from now, not 2 years, maybe next year or so, that I will start looking at some area where Altera has where commercially will be having interest into getting um, leading specific project, right? And one of these area again is around chiplet, right? Because we have been developing chiplet for a very, very, very long time, right? Our core FPGA is connected to the transceiver fabrics. There are individual chiplet on the package. That is how we historically have developed our product. We have used various technology, mostly recently where Intel developed technology, the EMIB, that you're probably familiar with, right? But now we are separating from Intel. We need to figure out a way how to be not physically dependent on them, and also having some technology that is more industry accepted and that is also cheaper, right? Intel is not the cheapest technology out there.
Right.
It's not the cheapest fab out there.
Yeah. So keep a couple of things in mind. You know, large companies like Intel and Altera, it's usually hard to kind of uh, align with their commercial interests,
Yep.
especially as an individual. We do have a individual membership where you can contribute as an individual.
Mm-hmm.
So a lot of our volunteer members are like that, that they are interested in developing certain proficiency and they come and participate and they don't want to burden their companies with all the paperwork. So so that is definitely an option. Give me.
Yeah. So Altera is a member. If you're talking about being member of OCP, yes, Altera is a member of OCP, right?
Yeah.
They definitely they have a membership for sure through Intel, but also, I mean, Altera has a membership at OCP. But in terms of me having my direct group participate in a chiplet economy or industry or standardizing something in the industry for the chiplet for chiplet. And that is something, like I said, it's going to take me a while to kind of understand what's going on before I trying to see if or ask internally if something that the company wanted to commit. So I need to learn myself first.
Yeah,
All right.
sure. That makes a lot of sense. Hey, David.
Hi, sorry I'm late.
Yeah. So David, we have a new participant, Aureline from Altera.
Oh, hello.
Hello. Hey,
Nice,
David.
nice to meet you again.
Yes, nice to meet you again. I don't know, I thought I called in this meeting once before, but maybe it was way back and then I forget. But definitely, because I've been having this in my calendar for a long while. And so I'm again, I was talking to Jawad here that, hey, I'm part of Altera. Of course, Altera is being developing Chiplet. Our products, our standard product is chiplet based, and our Algilex family is like its main fabric, and then up to 4 or 5, up to 5 smaller chiplets. So you can have up to 6 little dials on the package, right? And based on the AIB and stuff like that, the topology. But here today, for me, it's kind of a learning activity first, kind of learning what's going on at the OCP level, and then learning what's going on with this chiplet economy workstream, understanding what's going on. And then in the next few months or so, I can see if Alteras can be actively participating there. But myself, I'm more than happy if there's any work that you guys are doing and you believe that technically I can personally contribute, I'll be more than happy to roll up my sleeves.
Wonderful. That's great. Yeah, also we have a few work team under Open Chiplet Economy. So there is a lot of work to be done. So we are definitely happy to have you here.
Okay.
So David,
Okay, well, that being said, I'm going to sit back and then listen a little bit.
So David, it seems like you guys have spoke before. So have you described the work that you've been doing with Georgia Tech?
Yeah, just got off the meeting with Georgia Tech. I'm not sure if all the details are well known, but yeah, we are setting up a kind of demo design to play with chiplets and see where the issues are. And this is a this activity started at CDX because the background is we worked on white paper describing flows. We worked on several data exchange formats to carry data, and we said, hey, why don't we put the rubber on the road and see how these models work, what the flows are, what the gaps are. So that's a demo design. It's basically at the high level, it's a CPU chiplet, and we have 4 instances of that. And HBM4 die, we have 4 instances of that. The CPU chiplets talk to each other through UCA by 32, and they talk to each CPU talk to one HBM. So that's why we have 4 and 4. We could have made that bigger, but we want to maintain that to a same level to work with and to experiment, right? We can make it 10 CPU chiplets with 10 HBMs, but just the data gets bigger and the quality of results is not changing much. So that's why we kind of settled on 4 and 4. Putting that on a glass substrate with rules coming from Georgia Tech. So right now, the way we are is we have the CPU chiplet setup ready to go. We have the HBM setup ready to go. Working on the substrate, just created the placement and substrate level netlist to get it into layout. And start a little bit layout activities and see how, especially routing and signal integrity is going to look like for those designs. So that's where we are. In parallel, we'll try to run the CPU chiplet is based off of Ariane RISC-V core. The way we did it is we just took out the caches and put them into the HBM die so that the CPU cores talk to the caches through UCAE. And not very optimal, but we wanted to have that separation a little bit, right? What kind of to mimic a communication between compute die and memory die. So we will try to, we have a preliminary layout. It needs a small update because the boundary netlist kind of changed. The wrapper netlist changed. That's actually the only change in terms of logic inside is still the same. But what we are looking to do in parallel, run some simulations and get power for those cores, get power vectors, get waveforms, and then we'll try to see how PI looks like, power integrity, how power integrity looks like, and how thermal looks like. Yeah, so that's where we are with that design. There are some parts of it which are contrived, just due to the nature of the fact that a lot of the information that exists is proprietary, right? We don't have open UCAE 5, for example, or open HBM 4.5. So we're kind of contriving those pieces, but in terms of workflow, right? Again, the idea is to exercise the workflow and models. In terms of workflow, it doesn't really matter whether a PHY has an actual block with models or just a simple wrapper module, right? Without actual PHY, right? We can still see the data going through. Performance-wise, probably it's not going to be very accurate, but that's a different topic that I think falls one idea outside of what we're trying to do. Performance is something that the modularity workstream is heavily looking into. Yeah, so that's about the design that we have in CDX and where we are with.
So, David, the student is coming to the global summit for the talk, right?
Yeah, so can I ask a slightly, it's a related question to the talk, but I actually have a question about that. The format changed a little bit, right? We submitted a talk, but I think the format changed where it's 4 of us in one session. Our slides are due by Monday, and I'm a little bit confused what the format of that session is going to be. Is it going to be short presentations and a panel afterwards, or how that is going to look like?
Okay, so I'll be able to give you an answer after the next meeting where we are just trying to finalize the plan.
Okay. When is your next meeting? Because we need to put in some slides by Monday. So would we align on that?
We can get you some leniency on that one, but I'm talking to Anu around 11 o'clock on this topic.
Oh, okay. All right. Okay. So today. Okay, that's fine. Yeah. And anyway, I'm not ready with the slides. So any information before, by the end of today is going to be good. I was planning to open the slides on over the weekend and on Monday. Okay. Okay. So you were asking about you were asking a question about the student.
Yeah.
Yeah, so yeah, he we'll try to get him to come and talk about his work. He's been doing a lot of the work for this design. And I think he's a PhD student at Georgia Tech. And I think it's going to be good for him to showcase the work that was done. And it's going to be good for everybody, right? Chiplets are a pretty hot topic these days. So talk about some of the issues we are seeing, some of the successes we've had, and so on.
So what are some of the challenges that you think POC Workstream can help with?
So there is some work that it's the first thing comes to mind is just it's about time and resources, right? Uh, right now, it's the student that's doing 80-90% of the work. I'm doing a little bit of work as well, right? So that makes it a little bit slow going. Probably maybe useful to have other people help us out a little bit in any way that can help. Some of the challenges are probably helping us. I don't think we are going to get actual UCAE or HBM5 models, but definitely I think it would be very helpful if we get a guidance on what is appropriate way to set up the SI simulations in terms of signaling, right? What are the appropriate runtimes for signals, pre-emphasis, voltage levels, all the gory details about the two protocols. That is going to be extremely helpful to help us basically it's twofold, right? One is have a meaningful result, right? That the result kind of applies to anybody who's trying to do HBM or UCA integration. And second is the sooner we get the information, it's going to help us plan the routing a little bit better, right? I expect routing in SI to be quite challenging in this one. So the sooner we start tackling those two kind of the accuracy of assumptions that we make, the better outcome we are going to get is what I'm thinking.
I see. So you are thinking about signal integrity simulation workflow and like a sign off. Is that what you're thinking?
Yes, basically it's related signal integrity and how those signals need to be routed. What are the what assumptions do we need to make in terms of line space, layer thicknesses, something that is going to work, right? Basically the so-called early analysis of SIPI or SI, right? Kind of planning for the routing topology and the stack up. Right. In this case, the stack up we're going to use is going to be close to what Georgia Tech has in their lab, but we have a little bit of freedom to uh, make it something that is close, but not exactly what's coming out of the Georgia Tech lab, merely for the purposes of ensuring that showcasing that, hey, to have a successful SI sign off, when you start early planning, this is what we plan for, which is a little bit more advanced than what the technology has. And this is what we used. And then we do the layout and simulation and kind of show that, okay, this is what we assumed and it actually works. That's kind of what I'm thinking.
I see. I think that's a topic that JP was very much interested in, no?
Yes, probably, yes. So maybe there's something that he can help us out with.
Mhm. But there's a bigger question, which is, so you are using UCIe, whatever you can find in the public domain, right?
Right.
So I'm assuming companies that are selling UCIe, they do provide IBIS models, but they have no clue what the channel model will look like.
That's right.
Do they even provide IBIS model already publicly?
Publicly, no. They all have IBIS model, and I don't expect we're going to get a proprietary IBIS model to work with.
Okay.
But what I'm hoping is if we get somebody could give us an idea what an IBIS model needs to look like that is going to be applicable to UCAE. right? We can handcraft an IBIS model like that, right? It doesn't have to be related to the proprietary IP. As long as it's related to the standard and captures all the necessary drive strengths and ramp times and pre-emphasis and any of that weird stuff, that will be very helpful.
Actually, I have a question, David and Orlean. Do you know if UCI is open source, or what part is open source? Do they provide these things?
Well, UCI is just like any protocol, just like any PCI protocol. The standards are out there; they are available. Anybody can design off of it. It is an open protocol. That's what if that's what I'm saying. But not everybody is going to build their own PHY and then try to sell to somebody who doesn't have time to build their own PHY. Was that your question, or I mean, I don't know. I'm not sure I understood.
Yeah, that was generally what I was trying to understand. So, David, if it's available in the open, I guess what you were saying is how do you take that information and convert that to IBIS, right?
Yeah. So in terms of openness, I guess open should be put in quotes. That isn't open. The specification is open to the members. I have been trying to get from the UCA consortium the UCA 2.0 and 3.0 specs. They have a checkbox in there saying, "Oh yeah, if you want it, just send us your email. Give us your email and we'll send it to you." And I've been trying to get that without success. Right, I fill out my information and they don't send me anything. I'm not sure if my email is blacklisted or I don't know what the deal is. But anyway, I don't have UCA 2.0 and 3.0 open specifications. I have seen those, but not in the open.
Oh, not in the open. Got it. So you mean if you get it with your company's email, you won't be able to use it in the design? I'm trying to understand. Maybe
You can. You can, as far as what I am deducting by not being able to get those specifications sent to me, is that if you're a member of that consortium, you will probably get the spec. Right, they have different levels, so probably the highest level of membership in that consortium, you can participate in the definition. The lowest level is you just get copies of the spec. I'm not a member of that consortium, and I didn't get the spec. I have seen the specs. Otherwise, I have seen the specs in clients, but I don't know if I can use that and take some of the data out in the open. I don't think I can. That's why I kind of put open in quotes.
okay. So yes, I think in that case I'm going to go out with you because I have seen UCI specs and I have access to them. I mean, I deal with it, but some other people in my company, I'm more like expert in UCI. I have gotten the specs on their website, but I didn't know that is something that that they are not providing just by asking, for example, like PCI specs or something like that.
Yeah, I again, it may be just me. I don't know, right? I did not receive the spec after my request. So I'm not sure what to make out of it, whether their system doesn't work and is broken.
And yeah, which email are you using? What company are you from again?
With Trace Systems.
Okay.
Did my Zoom thing not show the company?
No, it doesn't show the company you are.
Okay.
At least it's not like mine. I think you have to add it specifically.
Let's see. Let me put it in the chat.
Okay.
Maybe. Okay. Yeah, this is the company.
Yeah, okay. Yeah, so again, I don't know. I know that I have access to UCI, so I mean, I'm not sure. So how I'm not sure how to help exactly here. But what I was trying to say that for all the help that you have rattled off, I know at this moment your urgent help is on UCIe. Sorry, it's on SI. IB's model generation. That's not something. It's something that's going to take me a lot of time to do. But if it comes that you need help in PI, PD, or anything that's power related, maybe at the interface level, maybe not exactly like silicon level, but you need something that's PI related. Maybe that's where I could be useful if possible.
Okay. Okay. Yeah. Yes. Thank you. I'll keep that in mind.
So I have a couple of thoughts, David. I can certainly send a email to Debendra and I can ask him. My understanding is they probably are not going to give it to an OCP project, but with a commercial company email account, it's a different story.
Well,
But I'll try to figure that out. Why is it that you are not getting the spec? I mean, we can open a conversation with him and see what's the reason. My suspicion is just the way they set up the thing. Their IT system is probably not doing what it's supposed to do.
yeah, maybe I just wasn't sure where to whom to reach out to get this
Yeah.
issue resolved.
But the thing is, if the spec is not available on the internet, then how can it be called an open spec, right? But that's a topic for some other day.
Yeah.
For first order, we need to get the 3.0 spec, right? Not 2.0 is irrelevant now.
Yeah.
So because they've increased the speed to 64 and added some other things, it probably will change the IBIS model and some of the other requirements. And then it also sounds like somebody making an IBIS model and just publishing it will help UCIe ecosystem,
Yes.
right?
Yes. I think that's going to be extremely beneficial. Just kind of a vanilla UCI model that's going to be super cool.
Yeah. Okay. Then there was other interesting comment that I heard from Arlene about the power integrity and some of the challenges that we have been seeing, not in particularly in this working group, but in general at OCP, where people are talking about thousands of amperes,
Yes.
right? 800 volts and thousands of amperes and multiple layers of interconnects. And my head hurts even thinking about how to design and model any of that.
So maybe a question that's appropriate to this is one thing that I guess the question is like this. What are the power challenges that we can demonstrate with this design? What are your thoughts on that? That's a question for Aurelian.
Since I don't understand a little bit of this, I don't understand the design, I'm not sure I can answer that directly. But in general, I think the power challenges are going to be for any chiplet. It's going to be power delivery. It's going to be power integrity. in general. But to be specific, I need to kind of see the design itself, which I
Okay.
have not. So it's kind of hard for me to answer the question directly.
Okay. Yeah, maybe we can talk offline a little bit. Right. Definitely. Here's the challenge we have right now is we use the RISC-V cores SS, and we'll get power waveforms out of them, whatever comes out. And what we don't know, what we are running blind with, is we don't know yet. Are we going to have any power challenges with this, right? Or is it going to be pretty straightforward, right? And the question is, can we plan this design around some of those power challenges and see early on whether the data we are generating is going to hit on those power challenges, kind of make the whole design a little bit cooler, you know? What do you think about this, if it makes sense?
So no, I think for any chiplet design, the base in any chiplet based design, we're going to have a lot of challenges in terms of mostly coordinating voltage level between the various chiplets that are going to be on package, the voltage regulators, making sure that we have a reduced number of voltage regulators on the motherboard to feed power to all the chiplets. Let's say if individual chiplet comes with 2 or 3 voltage levels that are different from each other, you put 4 of them, that's already 4 multiplied by 3 times 4, that's 12 voltage regulators that you need on the package, especially if their level or the tolerance is such a way that you cannot merge them at the board level, then that would be the challenge. So I see that would be the PD level, power delivery level challenges. Now, when you go on package, you need to make sure that you have enough layers to provide to route power in there. And because you are multiplying the number of rail, you're multiplying the number of layers for your package. Therefore, you're increasing the cost and all those kind of stuff.
That's what you're saying. Actually, is very, very interesting. The chiplet itself is going to have a few voltage levels, right? Because we have a core voltage, and then we have a voltage for all the UCAEs, and then for the HBM we have, I believe, 2 voltages, right? I mean, for the PHY itself we have 1 or 2, and then on the other side for the HBM itself we have 3 or 4, if I'm not mistaken. So I was actually exactly thinking about that part, the regulators, how to set them up in a meaningful way. So maybe we definitely should talk about this, right? And where to place them. I think we want to make this design a little bit challenging, right? Such that we can show some interesting results, but not so challenging such that it becomes a commercial level difficulty project, right? Because we are all volunteers working our free time on this, and definitely don't want to spend our days and nights on this trying to figure it out, right? And it's just few of us. So maybe why don't we think about set up some time next week? I can go over the design, and we can kind of make a first guess on how we want to handle the voltage regulation, what would be interesting case study, and kind of go from there and see what comes up.
David, you're welcome to use this time slot. We don't have to use the Zoom link if you guys are private.
Okay, yeah, it's fine. Yeah, okay.
Yeah, absolutely. I mean, this slot works perfectly for me. So I'm more than happy to start to jump in the call there and learn. So we can talk about those challenges.
Okay, let's then next week we'll talk about power in this meeting, what the design setup is. I think power is going to be very interesting to the PhD student also, because he's looking into, I think we'll know next week what his thesis project is going to be. And I suspect it may be power related. In any case, he expressed interest in power. So maybe if this is related to power, maybe apart from him, even his professor's lab, if there's other students working on stuff, on power related stuff, this may be interesting to them as well. So that will help us get a little bit more manpower behind us.
Okay, absolutely. And are they going to be on the call next week when we talk?
I will invite him. I'll tell him to show up this time. Hopefully he won't be busy with other stuff. I will, I will invite him.
Okay.
Okay, that sounds great. So very organic discussion.
Okay.
So I don't have any other topic to discuss, David and Orlean. If you have any other topic to discuss, happy to talk.
No, I don't have anything else specific.
Okay. Yeah. I don't have anything either. So
Okay.
next week we can talk about power and how do we make that power delivery network. I definitely want to have. I was exactly thinking about that, having some regulators on the package, make it a little bit more interesting, right? With integrated VRMs being kind of the next hot thing, and see what interesting stuff is in there.
And you will give an overview of the design as well, right?
Yes.
Okay. Sounds good.
Okay.
Then see you guys next week.
Yeah. Talk to you next week.
All right. Okay, guys. Take it easy. Bye.
Yeah. Bye.